Imagine a world where everything is backwards, where ice is as hard as rock and geysers shoot ice into space. A place where a moon is actually orbiting in the opposite direction of its host planet. Welcome to Triton, the bizarre and mesmerizing moon that defies all expectations and challenges our understanding of our own solar system. Neptune. Neptune is the eighth planet from the Sun and the farthest known planet in the solar system. It is the fourth largest planet in the solar system by diameter, the third most massive planet, and the densest giant planet. It is 17 times the mass of Earth, and slightly more massive than its near twin Uranus. Neptune is denser and physically smaller than Uranus because its greater mass causes more gravitational compression of its atmosphere. Discovery. Triton was discovered on October 10, 1846, by British astronomer William Lassell, just 17 days after Neptune itself was discovered. Overview. Triton is the largest of Neptune's 13 moons. It is unusual because it is the only large moon in our solar system that orbits in the opposite direction of its planet's rotation, a retrograde orbit. Scientists think Triton is a Kuiper belt object captured by Neptune's gravity millions of years ago. It shares many similarities with Pluto, the best-known world of the Kuiper belt. Like our own moon, Triton is locked in synchronous rotation with Neptune. One side faces the planet at all times. But because of its unusual orbital inclination, both polar regions take turns facing the Sun. Diameter. Triton has a diameter of 1,680 miles, 2,700 kilometers. Spacecraft images show the moon has a sparsely cratered surface with smooth volcanic plains, mounds, and round pits formed by icy lava flows. Triton consists of a crust of frozen nitrogen over an icy mantle believed to cover a core of rock and metal. Triton has a density of about twice that of water. This is a higher density than that measured for almost any other satellite of an outer planet. Europa and Io have higher densities. This implies that Triton contains more rock in its interior than the icy satellites of Saturn and Uranus. Atmosphere. Triton has a tenuous nitrogen atmosphere with trace amounts of carbon monoxide and small amounts of methane near its surface. Like Pluto's atmosphere, the atmosphere of Triton is thought to have resulted from the evaporation of nitrogen from its surface. Its surface temperature is at least 35.6 K minus 237.6 degrees Celsius, because Triton's nitrogen ice is in the warmer hexagonal crystalline state, and the phase transition between hexagonal and cubic nitrogen ice occurs at that temperature. An upper limit in the low 40s, K, can be set from vapor pressure equilibrium with nitrogen gas in Triton's atmosphere. This is colder than Pluto's average equilibrium temperature of 44 K minus 229.2 degrees Celsius. Triton's surface atmospheric pressure is only about 1.4 to 1.9 pa, 0.0140019 bar. Orbit and rotation. Triton is unique among all large moons in the solar system for its retrograde orbit around its planet. It orbits in a direction opposite to the planet's rotation. Most of the outer irregular moons of Jupiter and Saturn also have retrograde orbits, as do some of Uranus' outer moons. However, these moons are all much more distant from their primaries and are small in comparison. The largest of them, Phoebe, has only 8% of the diameter and 0.03% of the mass of Triton. Triton's orbit is associated with two tilts: the obliquity of Neptune's rotation to Neptune's orbit, 30 degrees, and the inclination of Triton's orbit to Neptune's rotation, 157 degrees. An inclination over 90 degrees indicates retrograde motion. Triton's orbit precesses forward relative to Neptune's rotation with a period of about 678 Earth years, 4.1 Neptunian years, making its Neptune orbit relative inclination vary between 127 degrees and 173 degrees. That inclination is currently 130 degrees. Triton's orbit is now near its maximum departure from coplanarity with Neptune's. Physical characteristics. Triton is the 7th largest moon and 16th largest object in the solar system and is modestly larger than the dwarf planets Pluto and Eris. It is also the largest retrograde moon in the solar system. It comprises more than 99.5% of all the mass known to orbit Neptune, including the planet's rings and 13 other known moons, and is also more massive than all known moons in the solar system, smaller than itself combined. Also, with a diameter 5.5% that of Neptune, it is the largest moon of a gas giant relative to its planet in terms of diameter. Although Titan is bigger relative to Saturn in terms of mass, the ratio of Triton's mass to that of Neptune is approximately 147.88. It has a radius, density, 2.061 grams/chem3, temperature and chemical composition similar to that of Pluto. Surface features. All detailed knowledge of the surface of Triton was acquired from a distance of 40,000 kilometers by the Voyager 2 spacecraft during a single encounter in 1989. The 40% of Triton's surface imaged by Voyager 2 revealed blocky outcrops, ridges, troughs, furrows, hollows, plateaus, icy plains, and a few craters. Triton is relatively flat. Its observed topography never varies beyond a kilometer. The impact craters observed are concentrated almost entirely in Triton's leading hemisphere. Analysis of crater density and distribution has suggested that in geological terms, Triton's surface is extremely young, with regions varying from an estimated 50 million years old to just an estimated 6 million years old. 55% of Triton's surface is covered with frozen nitrogen, with water ice comprising 15 to 35% and frozen CO2 forming the remaining 10 to 20%. The surface shows deposits of tholins, organic chemical compounds that may be precursors to the origin of life. Cryovolcanism. One of the largest cryovolcanic features found on Triton is Leviathan Patera, a caldera-like feature roughly 100 kilometers in diameter seen near the equator. Surrounding this caldera is a volcanic dome that stretches for roughly 2,000 kilometers along its longest axis, indicating that Leviathan is the second largest volcano in the solar system by area, after Albemarle's. This feature is also connected to two enormous cryolava lakes seen northwest of the caldera. Because the cryolava on Triton is believed to be primarily water ice with some ammonia, these lakes would qualify as stable bodies of surface liquid water while they were molten. This is the first place such bodies have been found apart from Earth, and Triton is the only icy body known to feature cryolava lakes, although similar cryomagmatic extrusions can be seen on Ariel, Ganymede, Charon, and Titan. In conclusion, Triton is an incredibly fascinating moon with a unique and mysterious history that continues to captivate astronomers and space enthusiasts alike. Its backwards orbit, icy surface, and active geysers make it a one-of-a-kind celestial body in our solar system. As we continue to explore and learn more about Triton, we are sure to uncover even more secrets and surprises that will deepen our understanding of the complex and dynamic nature of our universe. Who knows what other discoveries await us in the vast expanse of space? For now, we can only look up and wonder at the beauty and complexity of Triton and the other fascinating objects in our cosmic backyard.